Good morning, students. Welcome to another session of chemistry, and we are going to continue with our chapter 2, acids, bases, and salts, and this is part 2 for the same. Before we go into the new topics of the chapter, I would like you to revise few things which we did in the last session. So, this one is the recap from the previous session. In the previous session, we have studied what are acids and what are bases. So what we have done is the basic properties of acids and bases we discussed, like acids are sour in taste and bases are bitter in taste, and how they turn the litmus paper blue to red and red to blue. So you must remember what color of litmus paper is changed by acids and bases. Next we went to the indicators, and we define indicators as the substance which changes color when it is added to acids or bases. And indicators were of two types that we discussed. They are of two types, natural and synthetic indicators. So we gave the examples of natural indicators like red cabbage leaves, turmeric, and synthetic indicators like phenolphthalein, methyl orange, etc. we discussed. Next we went to the organic and inorganic acids. So acids can be classified into two groups on the basis of how they are available in the nature, or they can be manufactured in laboratory. If they are available in the nature, then they are known as organic acids, and if they are manufactured in industry only, then it can be inorganic. They are called inorganic acids. Organic acids, we also discussed about many examples, like in the kitchen all the sour substances they contain acid. So we give example like vinegar, which is acetic acid, tamarind containing tartaric acid, tomatoes containing oxalic acid. So please remember these names for short questions, or MCQs can be asked that name the acid present in tomatoes, or name the acid present in lemons. So all these things you have to remember. Inorganic acids, we gave examples like nitric acid, sulfuric acid, and hydrochloric acid. For you, it is very important to remember the formulas of these acids. Next is, we gave examples of common acids that we did, and examples of common bases. So common bases, I gave you the examples like NaOH, KOH, sodium hydroxide, and potassium hydroxide. And I also told you that there are some bases which are available in our households like baking soda, NaHCO3, and washing soda, Na2CO3. So this was about the previous session. I gave you the worksheet as well. So please solve the worksheet if you have not solved yet, and check the answers which are given at the end of this session. So please go through the worksheet and the answer key at the end of the session. Now we are going to start with today's session. So today, what are we going to learn in this part 2? So we need to go to the so today we are going to learn about chemical properties of acids and bases. So we have studied about some properties like how it changes the color of litmus paper, how the acids are sour in taste, how it looks like, and what is the color and everything. So all these things are physical properties which tells about the physical appearance. But chemical properties are different from physical properties. The chemical properties, they tell us how acid reacts with certain substances. For example, metal, for example, oxygen, for example, water, for example, base, so acid plus base, all these things. And when it undergoes chemical reaction, it forms products. So we are going to learn many chemical reactions of acids and bases, but in general they follow a particular trend. So it's easy for us to predict the product when we know what is the trend that acid is going to react with, and we can easily predict the product about acids and bases. So please give the heading for today's topic in your notebook: chemical properties of acids and bases. Now, this is the first chemical property. If we can see over here, this reaction of acid with metal, right? So reaction of acid with metal, although it's difficult to read because it is just hidden behind something, but it says reaction of acid with metal. So give first number, reaction of acid with metal. So here it's a demonstration of the reaction. Actually it will be easier to understand when we see the demonstration. First of all, this is the apparatus shown in the diagram, and here we can see this is the clamp on which a test tube is kept properly, right? And this is the delivery tube which is going from here to here. Now this is the beaker which contains soap solution, right? So here we got a test tube in which we are going to mix two substances. One is acid and one is metal. So the acid we are going to take over here, you can see which acid we are taking here is dilute sulfuric acid. So H2SO4 we are going to take, and also the metal we are going to take is zinc. So zinc granules we are going to take. Granules means small pieces, very small pieces of zinc, plus dilute sulfuric acid. Dilute means a lot of water is added into it. As such, sulfuric acid is a very harmful chemical, very corrosive. So you cannot use concentrated sulfuric acid, and you have to dilute it many times with water so that it becomes less and less harmful. So after mixing these two, what are we observing? We observe hydrogen gas bubbles. You can see some bubbles over here in the test tube. So hydrogen gas bubbles are evolved through the test tube. And what happens to this hydrogen gas bubble? How do we know that it is only hydrogen? For that, what we are doing is we are passing this hydrogen. After getting these bubbles, we are passing this hydrogen through the delivery tube, and where it is going we can see, right? So here we can see hydrogen is passed through the delivery tube, and then it is going to soap solution over here which is kept in the beaker. In soap solution it creates many number of bubbles. Now all these bubbles will contain hydrogen gas. Now this hydrogen gas, how can we test it? If we bring a candle near these bubbles, then we are hearing the burning of hydrogen gas, and it will create a popping sound. So after bringing the candle, this is the candle we are bringing near, so we are hearing the popping sound over here. So that shows that the gas which is inside the bubbles, it is a combustible gas, means it burns itself with the help of some ignition temperature. And that's how, and we know the property of hydrogen from the previous standards, that hydrogen is the gas which is a combustible gas. Nowadays we are using hydrogen as a fuel as well. So that means that what are we concluding from this experiment? Once again I'm just going to zoom it out. So here we can conclude that when we mix this zinc and sulfuric acid here, and when the gas is passed through the soap solution, the bubbles, they are producing popping sound. The conclusion is when acid reacts with metal, it produces hydrogen gas which produces popping sound with the candle. So that means when the reaction takes place between acid and metal, then we get hydrogen gas. So that is the most important thing for you to remember. So in the next slide we see some chemical reactions now. I hope this thing is clear. Actually I would like you to draw this diagram. It is given in your textbook as figure 2.1. You can see over here. You can find that and draw this diagram, and then so maybe just leave some space for the diagram and label it carefully. And then if you go, then next slide, write this chemical reaction. So we have given the heading actually. The main heading was the chemical properties of acids and bases. Then the next heading, number 1, reaction of metal with acid or reaction of acid with metal. And then we drew that diagram, and then after that we are writing this chemical reaction. What is the chemical reaction associated with that diagram or with that experiment? So here this is the general thing we are going to write down. Always it is true for any acid, true for metal. Acid plus metal gives salt plus hydrogen gas. So it's going to give us salt and dihydrogen gas is produced. So remember, wherever acid is present, any acid, wherever metal is present, salt and dihydrogen gas is obtained. Here we can note it down. There are few exceptions. So what are the exceptions? That is HNO3, nitric acid, which is itself a oxidizing agent. HNO3, I gave you the formula in the last session. Itself as an oxidizing agent. So instead of hydrogen, it's going to produce what? Water, H2O. So if you take this acid as HNO3, it's going to give you H2O instead of hydrogen. But for rest of the acids like H2SO4 and HCl, the same reaction follows. So one exception you have to remember, HNO3, which is an oxidizing agent, instead of hydrogen, it's going to give you H2O. Right? If you go to the other acids, that is HCl and H2SO4, it's only hydrogen gas is produced over there. Now, talking about the metals. All the metals, they produce hydrogen gas, but 3 metals. So please write down the exceptions. So exception 1 is HNO3. Another exception will be the metals, that is gold, silver and platinum. These are the metals. They are going to give us salt and hydrogen gas. All the metals, they are going to give us salt and hydrogen gas, but except gold, platinum and silver, because they are very inert. They don't react with anything. So inert metals, even it is given in your textbook also. So write down the metals which are gold, silver and platinum. Inert metals, they do not undergo this reaction. Otherwise, all the other acids and metal, they give us this reaction. Once more, going to this slide again. Once more, what you have written is this reaction, and we have written exception number 1, HNO3, which is an oxidizing agent. So instead of hydrogen in this reaction, it's going to give us water. Another one exception is gold, platinum and silver, which are inert metals. When they react with acid, they do not give any reaction. So here we can write no reaction. Okay, going back to the previous experiment which we did, this is the chemical equation which we can write down here. So we have taken zinc, we have taken sulfuric acid dilute in the test tube. So here we are going to get salt plus dihydrogen gas, right? So zinc plus H2SO4 gives you salt plus dihydrogen gas. Here we can see that what kind of reaction is taking place. Zinc combines with SO4 to give ZnSO4 and hydrogen goes outside. That means it is a displacement reaction taking place over here. Similarly, we can see the other reaction. Instead of H2SO4, if we take HCl, another acid, then we get ZnCl2 plus hydrogen gas go away and takes the place of zinc. ZnCl2, because Zn is plus 2 and Cl is minus 1. If you cross multiply, you will get the formula ZnCl2. So that is a salt. These two are the salts and this is hydrogen gas. So this fulfills the reaction. We see how we can write down the products for the unknown reactions now. So going to the next slide. Here, this is a blank slide. More reactions are going to come up. So more examples of the chemical reactions. First example is coming up. I hope you can read it properly. This is Fe plus HCl, and what is the question mark? Actually, question mark is on the right hand side, so you have to predict the product Fe plus HCl. So here we can see, analyze. Fe is iron, which is a metal. HCl is a acid. So metal plus acid gives you salt plus dihydrogen gas. What kind of salt is going to be formed? So salt here with the help of Fe and Cl, right? Now Fe is plus 3 and Cl is minus 1. The formula will be FeCl3. Hydrogen is going out as H2 gas. So what will be, and we have to balance the equation as well. So this one you are writing in the notebook, more examples of the same property, right? So next one is coming up. The answer is coming up now. 2Fe plus 6HCl gives 2FeCl3 plus 3 hydrogen gas. 3 times H2. 2FeCl3 plus 3 times H2 is our product. Okay, so that's our product. Going to the next example, we have to predict the product again. Zn plus H2SO4. Then what is the product? So that is ZnSO4, because we know Zn is, this Zn is again metal, this one is acid. Zn combines with SO4 and hydrogen goes away. So product will be, what will be the product? ZnSO4 plus H2. The arrow coincides because it has been done on the computer, so it's not formatted for mobile, so please watch on the computer. Here ZnSO4 plus H2 is the product. So write down this another example, second example. One more example, Na plus CH3COOH. Now CH3COOH, this is acetic acid. So if you don't remember the formula, if you don't know the formula, please write down as a note just at the corner, so that you can read it when you are reading through the books. So acetic acid formula is CH3COOH. Now here this hydrogen at the corner is going to be displaced by Na. So what is the product you are going to get? Hydrogen is going away, Na is coming here. So what is the product you are going to get? It's coming up now. 2Na plus CH3COOH gives you, where is the arrow gone? I think the arrow is missing. Yeah, arrow is coming up now. 2Na plus 2CH3COOH gives you 2CH3COONA plus H2. Now this is a salt, this is a salt, and this is a salt, and you can see this is hydrogen gas, hydrogen gas, hydrogen gas. So it fulfills the general formula that metal plus acid gives you salt plus dihydrogen gas. Any more example will be given, I think you will be able to find the answer, find the products for them. So this is about the first property of acids. We are switching over to the next property of acids. So we are going to the next slide again. Reaction of base with metal. So we studied about reaction of acid with metal. Now we are studying reaction of base with metal. Base plus metal gives salt plus dihydrogen gas. Again, the products are the same, so no need to remember much, but this is a different type of salt you are going to get. Here, if we see a particular example, NaOH, that is base, when reacts with Zn, it's going to give you Na2ZnO2 plus hydrogen, right? So Na2ZnO2, the name must be noted, so please note down this in your notebook as well. Na2ZnO2, the name is sodium zincate. That's another type of salt. So second property, first property we have already written, reaction of acid with metal. This is the second property, reaction of base with metal. Now I think you have written that one. Going to the next slide. So this is again more examples for you to practice, more reactions. If you are given KOH and Zn plus Zn. Then what will be the products? So these are the products for KOH and Zn. Just like Na2ZnO2, instead of, remember that potassium and sodium, they are having similar properties. So whatever is applicable to sodium, it is applicable to potassium in most of the cases. So here K2ZnO2 is the product plus H2, that is called potassium zincate, and 2 is written for balancing the equation. Next we are going NaOH plus Mg. So here also first analyze, this is base, this is magnesium. Base plus metal gives you salt plus dihydrogen. What kind of salt you're going to get? It's already here in front of you. Instead of Zn, you're going to get here Na2MgO2 plus H2. So remember the first product, Na2ZnO2, and Zn is having plus 2 valency. Similarly, this Mg is also having plus 2 valency. So it's going to form sodium Na2MgO2. That is the product over here. Going to the next property. So this one is reaction of metal carbonates and bicarbonates with acid. So to read this property, write down number 3 property, reaction of metal carbonates and metal bicarbonates with acid. Metal carbonates plus acid. First one I am reading. Metal carbonates plus acid gives you salt plus water plus CO2. So here one more thing is added, carbon dioxide, which is present in carbonates, and this is present in bicarbonates. So either you take carbonate, that is carbonate is CO3, this carbonate is CO3, bicarbonate is HCO3. When they react with acid, they both are going to form salt plus water plus CO2. So this one is the general reaction. Note this down, which is given in your textbook also. So reaction of metal with metal carbonates or metal bicarbonates. Metal carbonates plus acid gives you salt plus water plus CO2. Metal carbonates plus bicarbonates plus acid also gives the same. If we see the specific example, again one experiment type of thing is coming up. So here you can see what we can see in the apparatus. So here what we got, first one is what, this one is test tube. In the test tube, what have we got? We have got over here sodium carbonate, which is available in the form of solid, which looks like white powdery solid, looks like salt only, in which we are adding acid. The acid we are using is dilute hydrochloric acid, that is HCl. So our reactants are clear. Sodium carbonate, that is Na2CO3, and dilute HCl. When they are mixed together, again we see the bubbles. So what is the bubbles about? These bubbles are of carbon dioxide gas. Now this carbon dioxide gas, what we are going to do with that one? This carbon dioxide gas, when it is passed through calcium hydroxide solution, that is slaked lime. We have studied in chapter 1, when calcium hydroxide reacts with carbon dioxide, slaked lime, what is it? Becomes turbid. And these experiments we have done in previous standards also. So it becomes milky white solution when it is passed through calcium hydroxide. So we will see the reaction in the next slide. So here remember the reactants, which are sodium carbonate, Na2CO3, and dilute HCl, and we are going to write the products for the same. Next slide. Here we can see, if we zoom in, the reactants reaction occurring in the above activity are written. So test tube A and test tube B is mentioned because in A, Na2CO3, sodium carbonate was taken. We can repeat the experiment with another test tube which contains NaHCO3, that is sodium bicarbonate. So as I mentioned, the reactants are these two, Na2CO3 and HCl. And what are the products we are getting? We are going to check that out. Here we can see the products. Salt, that is NaCl, H2O plus CO2. Similarly, NaHCO3 plus HCl, when they are mixed together, NaCl plus H2O plus CO2. So in that test tube, carbon dioxide gas bubbles are formed and they are passed through lime water or slaked lime. This is lime water. COH twice. I told you to remember the formula in the chapter 1. Now when CO2 gas is passed, then we get white precipitates, CaCO3. Precipitates mean the solid stuff. So we can see here solid plus H2O. So remember to write these equations. These are given in your textbook also. And then one more thing. If this from this CaCO3, in this CaCO3 we pass more CO2, then it will form bicarbonate. This is calcium bicarbonate, Ca into bracket HCO3 twice. You can see that. I can zoom it. Yeah, CaHCO3 twice. This is soluble matter. So once it becomes white, turbid white, it means solid white is formed, things are formed, which is CaCO3. When more carbon dioxide is passed, it becomes the solution in water. So it's soluble in water, so it is transparent solution afterwards. So these are the things we have to remember. So major thing which we have remembered in the third property is metal carbonate or metal bicarbonate react with acid gives you salt plus H2O plus CO2 over here, right? So remember to write number 3 property and general formula, that is metal plus bicarbonate, acid plus metal carbonate bicarbonate gives you what? And then for the whole experiment, then draw the previous diagram, which is this one. It's not going now. Go to the previous slide. So draw this diagram which is given in the book and also write all the equations which are given in the next slide, which are all given in the textbook. So please refer to the textbook. If you can't find, it is comfortable. If you don't find, this is comfortable to write from the slides. Now, so just to practice more reactions with metal carbonates and bicarbonates, we are going to the next slide. So here, blank slide, more reactions are coming up. More examples come up. Now first, CaCO3 plus HCl. Anyone can name CaCO3? Name of CaCO3 is calcium carbonate. What is the product now? As we can see, actually, if you analyze what reaction is taking place, metal carbonate, calcium is a metal carbonate plus acid gives you salt plus water plus CO2. How salt is formed? Ca combines with Cl and hydrogen goes with CO3. So double displacement reaction taking place over here, and we are going to get the products which are coming up. CaCO3 plus HCl, 2 is written to balance here, gives CaCl2 plus H2O plus CO2. So metal carbonate, this is calcium carbonate plus HCl acid gives you salt plus water plus CO2. Salt is formed by double displacement. Ca combines with Cl and hydrogen goes with CO3, and then it will form H2O and CO2, right? Next reaction coming up, MgCO3, that is magnesium carbonate, when combines with H2SO4, then it's going to give us what? MgSO4, that is magnesium sulfate plus H2O plus CO2. right? And last one is KHCO3. Name of KHCO3 is potassium bicarbonate or potassium hydrogen carbonate. When reacts with HCl, it's going to give us KCl, which is a salt over here, H2O plus CO2, right? So please write down these examples, or you can write down some more examples if you are confident enough for the formulas. Once again, I'm reading the first one. CaCO3 plus 2HCl gives you CaCl2 plus H2O plus CO2. Next one is MgCO3 plus H2SO4 gives you MgSO4 plus H2O plus CO2. And last one, KHCO3 plus HCl gives you KCl plus H2O plus CO2. So please write down these things, right? Going to the next one. Too much acid produced in your stomach. Sometimes you get a lot of acidity in your stomach. Then what do your mom and dad or doctors advise you to do? Take a basic substance to destroy acid. So acid, when too much acid in your stomach over here in your liver, then you take a basic substance to destroy it. So what is the reaction taking place over here? We go to the next slide. This is called neutralization reaction, which was introduced in the trailer part, neutralization reaction. So here we can see when we mix acid and base are mixed together, we get salt plus water. We have studied these reactions, I think, in previous standards. So this is another property, I think it is fourth or fifth property, that acid plus base gives you salt plus water. So it can be any acid or any base. Neutralization reaction, please copy this. This is the next property which we are talking about. Acid plus base react to form water and salt, right? So if we take acid as HCl, base as NaOH, we are going to get H2O and NaCl salt. HNO3, nitric acid, if we are taking NaOH, reacts with NaOH to give H2O plus NaNO3. So different salts are formed. Here we are going to get NaCl plus H2O. So H combines with OH. So to make it more clear, in the first reaction, Na combines with Cl and H combines with OH. Basically this is a double displacement reaction. Also all these types of reactions are exothermic. If you touch the reaction vessel, then you will feel that some heat is liberated from the reaction, so it will become little warm. So these are double displacement reactions, also called neutralization reaction. Acid is getting neutralized. So if you get HCl in your stomach, then if you add base, not NaOH but any other base, NaOH is really harmful, so you cannot have it, but you have milder bases like NaHCO3, you will get salt, which is neutral, plus H2O. So once the neutral salt is formed, then your stomach acidity will be relieved. So that is the principle it is acting on. Next one is HNO3 nitric acid. HNO3 nitric acid. NaOH gives H2O and NaNO3. Here also double displacement reaction taking place. H combines with OH, Na combines with NO3, so we get salt, NaNO3, sodium nitrate plus H2O. More examples, more practice for this. Acid plus base gives salt plus water. So acid or base gets neutralized. Going to the next slide. More examples coming up. KOH plus HCl. How can you predict the product? Double displacement reaction taking place again. K combines with Cl, H combines with OH. So we get, what are we going to get? The product is coming up KCl, product is KCl plus H2O. So I read the equation for you. KOH plus HCl gives you KCl plus H2O. Write as more examples and it will be more clear. Next, MgOH twice, the name is magnesium hydroxide, combines with H2SO4 to give you magnesium sulfate plus H2O. So here you can see again MgSO4 is a salt, this MgSO4 is a salt and H2O. This is magnesium hydroxide, sulfuric acid, and Mg combines with SO4, hydrogen combines with OH, so you're going to get 2H2O, and these all the numbers are written to balance the equation. Next one coming up, NaOH plus CH3COOH. I told you this is acetic acid, and this H at the end is going to be replaced by Na. So you're going to get CH3COONA over here. See the products, CH3COONA plus H2O. This is known as sodium acetate, this one, and this one is acetic acid. So write down all these things in your notebook again as an example. So any metal, any acid or any base is given, you know that the product are water and base.